Hello. In this lesson, I want you to present the implementation of working with button and add some listeners and callbacks before we start to integrate it into coding. So it's very simple example. We have a button right here and we have two LEDs. If I press the button and hold it, green LED is turning on. If I release the button, it's turning off. When I press the button 5 times, the red LED will start to light for 5 seconds. So one pressed was made, 2, 3, 4, 5. Very easy. On this button we injected some callbacks with unit functions, like an action when it's pressing and an action when it's released. One more time. 1, 2, 3, 4, 5. Very easy. And as you can see, we have some logs. The name of the button and the state of the button. Control button was pressed or unpressed. And we have 2 injected lambda functions with 2 different states of the button. In this lesson, we are going to implement how to work with physical buttons, GPIO input pins, and how to add listeners and inject some functional to this button. So first, our step, let's go to the packages from the previous lesson. We already implemented some physical parts of our avatar. We fully implemented the LED functionality, and we have an empty class of our button. One more time. Here we connecting our logic with physical hardware and GPIO lines. So let's implement it. First of all, in the LED class we have a digital output. It makes sense that the button will be the digital input. Let's create some reference to work with button. Button input, it's a digital input, yes, and init our class build button. We need to provide incoming arguments, Pi4J context, and the configuration of our button. Pi4J and let config. Okay. Private phone. Build the button. Copy this. Incoming arguments. To build the digital input with Pi4J library, we first of all we need a some object as params for Pi4J builder. Let's create it. Well, params digital input, new config builder. We provided a Pi4J context and start to build the params. First of all, we made to provide an ID. It's a BCM connection type. I'm recommending to use it. And we have button input, name. Next we need a name, almost the same. And no, oh my god, it's wrong. Here is it. Here is it. Yes. We use an incorrect the source of arguments. Address. Here is the pin of our physical button. Yes, because we don't need the LED config, we need the button config. Let's copy it, so let's copy, and paste. Then button config, pin. We need the bounds is a system parameter. I'm recommending to digital input default the bounds. It's something kind electricity circuits and wires. Even when you unplug the physical electricity chain, the wire works like an antenna and emits some electricity field. You know that from case when you use a wireless charger for your phone. So this system parameter make a stable states between 0 and 1 or low and high voltages, because when you unplug or release your button, you never know what's happening in your electricity chain. Then pull resistance. From the previous lessons from our hardware config, we have a pull resistance. The default actually should be 0, and I forgot about one thing from previous lessons. When we parsing our configuration and map it to our local data class, let's go to configuration. I forgot to provide you. We need to inject one important property from here, from JSON library. JSON properties ignore unknown and true. If you will not set it, sometimes we will have real-time exception during parsing if we add some new unknown values. So just add this parameter as annotation from JSON library. Okay, and returning to pull resistance, here we can parse pull resistance from our configuration. So when button config pull resistance is 0, it means pull resistance pull down. I'll explain what it means. Give me 1 second. And pull resistance pull up, and else we have a parameter turn off, but I strongly not recommending to use this parameter. By default set it to pull down. So what means the pull resistance? when your button is unpressed, the chain is unplugged. You can provide a different states for it, digital 1 or digital 0, state low or high. So by default you can revert the default state for the button. When it's unpressed, you can provide the high signal, but by default it always should be pull resistance down. Okay. And the second, build. So this is our value as parameters. We use the builder and just build Pi4J, create params. Okay, our button is pressed. Now we want to add some listeners to notify the main thread when the button state was changed, when the user press the button or release the button. Of course, we have our interfaces and specific types of our body with specific functions. For example, for circuit board, we have the functions how to work with LEDs. Okay, let's add some new function. Add button listeners, because we want to add 2 listeners for different states for our button. Each button has 2 states. Okay, what we need to provide: button position in case when we have a multiple buttons in our config. By default it will be 0, and we may to provide some lambda functions to activate the part of code when the action becoming. So we have 2 states and 2 lambda functions. Action high, this how the unit lambda function was not returning anything. If you want to return something, you can change the unit type to provide something as callback. And action low. Okay, the same unit type and as default boolean type for this function. Okay, goes to the implementation and implement this function. To implement this function, first of all, we need to provide our lambdas directly to the button class. Okay, let's create a function. Add button listeners. We work with single button on this layer, so we just providing a unit functions, and in Pi4J digital input we have a system function add listener. Here we can get a state of event, of action. Digital state change listener. We just need to pass our argument as digital state change event. Here is it. Pass the type, and we can work with this event. If e state, it will return digital state, equal to digital state high, it means the button is pressed, but be careful, digital state and physical position of the button pressed or released depends on set pull resistance. Okay, here we, in case we just print it out like button input name was pressed, and for the future just leave the to do command add to event me for system events. Okay, and activate our lambda function, action high. Perfect. The same piece of code for low state, just unpressed, and like that. Yes, nothing special. One more time, we add button digital input listener provided from Pi4J library on this the lowest layer of our architecture. Then we can add it to our interface and implement it. Okay, let's implement it. Just provide some checks to prevent real-time crashes. If the button position less than 0, it not makes sense. Return false and start our coding. Button position, if button position less than body buttons size, because we can have multiple buttons. Okay, call this function button position from the function in our button class. Okay, and provide action high and action low and return true, else return false. Okay, that's all. It's really easy example. And do you know why it's easy? Because in previous lessons we provide some smart architecture in our project, and we can extend it and add new devices and parts of our physical device very easily. We will add some sensors, some displays as parts of our circuit board. When we have totally another type of our engine, of our robot. We will provide some engines, some visual cameras, some I don't know, LEDs, lights, sound speakers, something like that. That's why I spent a lot of time in first lessons just to create the architecture of our project. Okay, let's return to main class. We don't need anything of this. For here we can provide long max value. We don't need anything from this, we will erase it. Okay. Let's do the same. But we will work directly with our buttons. Add button listeners. Button position will be the first button. We have a single button right here. Action high. So to provide a lambda function, we can use like that. In this block we can provide a lambda function, and action low, the same lambda function. So what we wanna do if the button will be pressed. For example, we want to turn on the green LED. Okay, let's copy this one. LED on position. If action is low, we want to turn it off. LED off. The same LED. Okay. But what we want to do, if the button will be pressed 5 times, the same button, we want to turning on the second LED, red LED. The magic of this code, each the part of our physical sensors and devices what plugged to GPIO pins work in separated thread. So we just make commands for these devices and it will work. For example, what we need a counter to count how many times the button was pressed. Var counter equals 0 by default. When we press the button, we increase the counter. How we can check when the counter will be pressed 5 times? So after we turning off the green LED, we make a simple check. If counter more than 4, use this code and work with the second LEDs with first position, duration 4, 5, second, and reset the counter to 0. That's all. Very easy. We can launch it. It should to work. Let me press the button a few times and you see the logging, how it's work. As you can see, events, real-time events is logging. And why we add this piece of code? Okay, if I remove it, we do not have any job and threads. We just add some Lambda functions, but our application will be closed because all the code was launched and completed. As you can see, I pressed the button few times, but it's not triggering the event because we closed the main thread. So to keep and listen any our events, we should to add some empty infinite loop to our main thread. Okay, as you can see. That's all for today. Thank you for your participation and attention. Something more interesting will be provided in the next lessons. Follow my YouTube channel and subscribe if you wanna. Thank you.